Hello everyone. If you have spent years working with Canvas, this video is for you because the protocol you know better than anyone else is now being replaced. Yes, you heard right. Not tomorrow, not in 5 years. It is happening right now in the vehicle rolling off production lines today. The automotive Ethernet market was worth $3.36 billion in 2025. By 2034, it will reach $11 billion. The average number of Ethernet connections per vehicle is raising from 11 to 27 by 2030. And every single one of those connections runs protocol most engineers have never properly studied. Some IP, TCP, UDP, some IP, DoIP. This series will change everything. By the time we finish, you will understand every protocol, architectural decision, and every interview questions that comes with it. Let's start from the beginning today. To understand why automotive Ethernet exists, you first need to understand what Canvas cannot do. Canvas was designed in 1983 at Bosch for the world where cars had handful of ECUs that need to share simple data: speed, RPM, temperature, brake pressure, throttle position, and etc. Canvas was perfect for that world, but that world was no longer exist. A modern vehicle has between 100 to 150 ECUs, or even more, all communicating simultaneously. It has camera generating up to 50 megabytes of data per second each. LiDAR sensor processing millions of data points per second. A DAS system that need to share sensors fusion data in under 5 milliseconds. Over the air update system downloading gigabytes of software across the vehicle network. And CAN bus maximum speed is 1 megabyte per second. You cannot stream a camera feed over a 1 megabyte network. You cannot run autonomous driving sensors fusion over 1 megabyte networks. You cannot deliver a gigabyte software update efficiently over 1 megabyte network. Canvas is not broken. It's simply not designed for what modern vehicles require. This is not a flaw, this is physics. So the industry made a decision. High bandwidth, safety critical, latency sensitive communication moved to Ethernet. Simple, low bandwidth body control functions stay on canvas. Both coexist in every modern vehicle, but Ethernet is the future. And some IP is the language Ethernet speaks inside your car. Before we go further, let's be precise about what automotive Ethernet actually is. It is not the same as the Ethernet in your office or in your home router. A standard Ethernet was designed for office environment. Sealed cable, stable temperature, no vibration, no electromagnetic interference. A car is opposite of all that. Automotive Ethernet is a modified version designed specifically for vehicles. The key standard is called 100 base T1. One pair of unsealed wire, 100 megabytes per second, full duplex, designed to withstand automotive grade temperature, vibration, and interference. By 2030, 1000 base T1 becomes dominant, 1 gigabyte per second, over the same single twisted pair. To put that in perspective, CAN bus 1 megabyte per second, automotive Ethernet today 100 megabytes per second, automotive Ethernet by 2030 1000 megabytes per second. That is a thousand times improvement in bandwidth. And with that bandwidth comes a completely different communication architecture. Canvas uses a message based architecture. Every ECU broadcasts a message onto the bus. Every other ECU listener, every ECU decides whether the message is relevant or not. This works when we have only 10 ECUs. It does not scale to 150. Automotive Ethernet uses a service oriented architecture. ECU do not broadcast, they offer services. Other ECU subscribe to the service they need. This is the fundamental shift in how vehicle communication works. And some IP is the protocol that makes service oriented architecture works over Ethernet. We will go deeper in some IP in this series on video 3. First, Let's understand the full protocol stack that Ethernet brings into our vehicle. Every network protocol works in layer. Each layer has a specific job. Each layer talks to the layer above and the layer below. In automotive Ethernet, the stack looks like this. At the bottom layer, this is the physical layer. This is 100 base T1 or 1000 base T1, the actual wire, the electrical signal, and the hardware. Above that, the data link layer, Ethernet frames, MAC address, how the data moves directly between connected devices. Above that, the network layer, IP, Internet Protocol, how data is addressed and routed across the network. Above that, the transport layer, TCP and UDP, how data is delivered reliably and efficiently between applications. And at the top, the application layer, some IP, DoIP, the automotive specific protocol that use all the below layers. You already know TCP and UDP from your computer networking, but in automotive they are used very differently. That is how we will cover in video 2. Now let us focus why this stack matters for your career. Every automotive project using software defined vehicle architecture uses this stack. Every domain controller, central gateway, and every ADAS computer platform, they all run IP based communication. They all uses some IP for services. They all uses DoIP for diagnostic purpose. If you cannot read a some IP trace, you cannot debug the next generation vehicle. If you do not understand DoIP, you cannot run diagnostic on any vehicle built after 2023 at OEM level. This is not optional knowledge anymore. This is core automotive engineering. There is one more architectural shift you need to understand because it explains exactly why automotive Ethernet is accelerating so rapidly right now. Traditional vehicle uses a domain-based architecture. One ECU per function: powertrain domain, chase system domain, body control domain, infotainment domain, ADAS domain, and etc. Hundreds of ECU, hundreds of CAN network, kilograms of wiring. A modern BMW has over 5 kilometers of wiring harness weighing over 60 kilograms. That wiring harness is one of the most expensive and most complex component in the vehicle. The industrial solution is zonal architecture. Instead of domain based ECU, the vehicle is divided into physical zone: front left, front right, rear right, roof, and center. Each zone has one powerful zone control ECU. All sensor and actuators in that zone connect locally to a zone control unit. Zone control unit connect to the central vehicle computer over high speed Ethernet. Result: wiring harness weight cut to 30 to 50%, manufacturing cost reduced significantly, software updates, centralized new feature deployed over the air. This zonal architecture runs on Ethernet. The zone control unit communicate using some IP. The central vehicle computer runs diagnostic using DoIP. This is the architecture of every next generation vehicle program being deployed right now at every major OEMs, at Mercedes, BMW, Volkswagen, Toyota, and many more. The engineers who understand these architectures are the one getting hired on these programs. The engineers who know only Canvas are being asked to learn quickly or move to the legacy maintenance work. This is the reality of 2026. SumIP stands for Scalable Service Oriented Middleware over IP. It was developed by BMW and standardized through AutoSAR. The AutoSAR consortium, which includes BMW, Mercedes-Benz, Bosch, Continental, Denso, and other, defined the standard that every automotive supplier implements. Some IP solves a specific problem. IP gives you a IP address and routing. TCP and UDP gives you transport. But neither IP nor TCP nor UDP knows anything about automotive services. They do not know what a speed service is. They don't know how an ECU should advertise that it's offer a steering angle measurement. They don't know how another ECU should subscribe to the measures. Some IP adds that layer. It defines how services are structured, how they are discovered, how they are called, and even how the events are published and subscribed. Think of it like this: IP is the postal system. It delivers packets to the address. TCP and UDP are the delivery method, track and confirm for fast and untracked. Some IP is the language on the package. It says what it is inside. It says who ordered it. It says what is inside it. Without some IP, you have a network but no common language or service. With some IP, every ECU can find, call, and subscribe to any services in the vehicle network. This is what makes the software defined vehicle possible. In this series, we will cover everything you need to go from Canvas engineer to Ethernet ready engineer. Video 2 covers TCP and UDP in depth, not from the computer science perspective, from an automotive engineer's perspective. Why UDP is preferred for some IP event, why TCP is used for reliable service call, how timeout values are configured, what happens when a packets are lost. Video 3 covers some IP in full details. Service structure, method call, event and notification. How some IP headers format byte by byte. How to read some IP traces in wireshark. Video 4 will cover some IP service discovery and vSum IP. How ECU finds each other at startup, offer service, find service, subscribe event group, and how vSum IP lets you test all of this without physical hardware. Video 5 will cover DoIP in detail, why K-line and CAN diagnostics are being replaced, how UDS runs over DoIP, the DoIP session establishment sequence, entity announcement and activation, how to set up a DoIP session in the test environment. Video 6 will cover interview questions, the exact question being asked in automotive engineering interviews for some IP and DoIP roles with complete answers with the level of details that gets you hired. All tools to practice are free at autodevpro.tech. No logging is needed, no download is required. Run directly in your browser. If this video is helpful for you and you learned something new today, then please subscribe to autodevpro.tech and see you in the next video. Till then, take care and bye. Thank you.